Hello, Hornets. Welcome. Thank you for joining me today. We're going to be taking a look at solving exponential functions with common base. This is an Algebra 2 skill that is required for us to work in pre-calculus so that we can be successful working with logarithms. See, logarithms have a tendency to move back and forth between exponential form and logarithmic form through the process of exponentiation. So we have to expect that things like this happen, and therefore we have to know how to do these skills. So we're going to be taking a look at just a few of them to remind ourselves of the process so that we are successful. Here's our first problem that we're going to be working with. 36 times 216 to the negative 3r power equaling 36. Now, my first step, now please be aware I could always divide both sides by 36 and clean this up, but I'm not. I'm going to work with my powers of 6 so that I have everything in prime factorization, and then I'm going to work with that. 216 is 36 to the third power, and then I have 6 squared. I'm now going to multiply using my laws of powers, or properties of powers if you prefer, to get minus 9r equals 6 to the second. This gives me 6 to the minus 9r plus 2 equals 6 to the second power. And therefore, minus 9r plus 2 has to equal 2. Now, we can clearly see that when we subtract 0, we get 0 when we subtract 2 from both sides. And when we divide, our only possible answer is r equaling 0. So, not the greatest of examples, but it shows you the process that we have to do. Notice we have to get into prime factorization, get a common base all the way across, and then once we have the common base on the left and the right side, we can drop the base and solve for the exponent. Let's take a look at another example, one that isn't going to give us 0. Let's take 25 divided by 625 to the minus 2a power equaling 625 to the 2 minus a power. Alrighty, so step 1, get common prime factorization with the common base. That's going to be 5 squared with the common base of 5, 5 to the 4th power to the power of negative 2a equaling 5 to the 4th power to the positive 2 minus a power. According to my rules, we have 5 to the second. This is now 5 to the minus 8a equaling 5 to the 8 minus 4a. Negative exponent forces this to come up to the top, so I have 5 to the 2 plus, because of the double negative, 8a equaling 5, 8 minus 4a. I'm now going to drop the base. 2 plus 8a equals 8 minus 4a. And I'm now going to begin solving. Adding 4a to both sides gives me 12a. Subtracting 2 gives me 6. And a has to be 1/2. And that is my solution. Let's go ahead and take a look at another one. This time, let's take a look at 4 to the power of 2r minus 2 equaling 1 over 64. Now, if you want to try this, I recommend that you hit pause, give it a try, and then follow along with me to see if you were successful. I'm going to give a moment where you can pause the button and then come back. For those of you still with me, what we're going to do is we're going to be changing 64 into a power of 4. Keep in mind that any power will do, even 2. I just recognize that this is 4 cubed, and so I wanted to work with it instead. I'm now going to take this and call it 4 to the 2r power minus 2 equals 4 to the minus third. Therefore, 2r minus 2 has to equal minus 3. 2r has to equal a minus 1, and r has to now be a negative 1/2 power. So my answer for the third question is a negative 1/2. I hope that's the answer you got. Let's go ahead and take a look at another problem, see how that works. We have 625 to the negative v plus 2 equaling 1 over 25. Take a moment and see if you can do this, and I will pause before I begin. For those of you with me, let's just go ahead and continue. We're looking at 5 to the fourth power. So I have 5 to the fourth power, parenthesis to the negative v plus 2 is equal to 1 over 5 squared. This then gives me 5 to the negative 4v, and I have plus 8 is equal to 5 to the negative second power. And I now drop my base, so minus 4v plus 8 is equal to negative 2. We therefore get negative 4v is equal to negative 10, and when I divide, I end up with 5 halves equals v. I hope that was the answer that you got. Let's now take a look at something a little bit more difficult and see how that works. Now, remember, we're already at a high level of difficulty, so it's not so much being more difficult as just trying to be a little bit more complicated. Alrighty, so we're looking at this and we're going to be working with powers of 3. We can already see that this is 3 to the fourth power. I can tell you that this is 3 to the fifth power, so we shouldn't have to worry about anything. We're just going to do a substitution. 1 over 3 to the fourth. I'm going to go ahead and I'm going to call this 3 to the minus first to the 3v equaling 3 to the fifth power to the minus 2v. This is then 3 to the minus 4 times 3 to the minus 3v equaling 3 to the minus 10v. We're now going to get the common base on the left side with a minus 4. This is plus a negative 3v, which keeps it as a minus, allowing me to drop the base to have negative 4 minus 3v equaling negative 10v, which means that minus 4 is going to end up being negative 7v, and v will end up being 4/7. There's my answer. Let's try another one. 36 to the minus x times 6 to the third is equal to 36. Take a moment and see if you can do this, and I'll give you a moment to pause the video. For those of you still with me, let's go ahead and get it into powers of 6. 6 squared to the minus x times 6 to the third equaling 6 to the second. We then get 6 to the minus 2x times 6 to the third equals 6 to the second. For 6 to the minus 2x plus 3 equals 6 to the second. We're now going to drop the base and have minus 2x plus 3 is equal to 2. For negative 2x is equal to negative 1, and x is equal to a positive 1/2. Now, they don't get much harder than this. This is what it is. The only thing that could be different is that we have different bases. And if we have different bases, we have no choice but to work with logarithms, which is what our chapter is ultimately on. So this should be a basic skill that you should be able to do before you move forward. Make sure that you practice this as needed. I've given you some practice in your classwork that I hope will help you to get better. Thank you very much, Hornets, and I hope this has helped. If you liked this video and it was helpful, please remember to click like, and if you didn't, please give me suggestions on how I might improve. Thank you very much. Take care and be safe, and we'll see you later, Hornets. Bye-bye now. Cheers.